What code do you need to create a $1 billion NFT collection? Is the team behind board Ape Yatch Club the genuine author of their smart contract? The rarest ape could be sold for 10 times more than a floor ape. From a technical point of view, could the original distribution have been manipulated? Hi, my name is Emmanuel, Ponku on the Web3. I'm a Solidity developer, and on this video, we will review the code of a smart contract. But before we start, two things. First, you have the opportunity to choose the next contract I should review. For this, join the Discord and submit the project of your choice under the YouTube section. The link in the description below. And second, I have a present for you. I offer you the possibility to get a free NFT from my next collection, Mercenaries of Efyria. This is the first collection that disrupts the concept of private property using Web3 technologies. If you want a mercenary, you can get the OG role on Discord by posting a comment, sharing this video, or follow us on Twitter. Now, let's move to my screen. The first step is to find the address of the contract. You should be able to find it on the official website, but in case you don't know it, I recommend to use OpenSea in order not to be fooled by a phishing website. OpenSea is not famous for its transparency, but at least I trust them not to display scam links. On the collection page, I check that the collection is verified and that it's come from a verified account. If you don't see blue check marks here, maybe it's a new collection, or maybe it's just a low volume collection. In this case, I will just look at the data here. In case it makes sense, then I will click on this button, View on Etherscan. Etherscan is a block explorer and provides a lot of useful information. Here we can notice that we are on the contract. This is different from a wallet address. Also, we can notice that Etherscan recognizes this contract. We can see it here, the public name tag. Also, there is like this icon on the token. Some other information I like to check are the amount of transactions, or if the contract holds any Ether or any other token. We might also want to look at the deployment date. To find the deployment date here, under the contract creator, you will see the hash of the transaction. If you look at it, under the timestamp field, you find the deployment date. The part that will interest us is under the contract tab. The green mark indicates that the contract source code is verified. This does not mean that the code isn't malicious or without bugs. It only means that the source code submitted by the contract owner is identical to the bytecode deployed on the blockchain. If we scroll down, we can find different sections. The contract source code. In this section, we will find the source code of the contract. In case you don't find the source code here, this means that this contract isn't verified because the owner hasn't provided the code. It is still possible that you find the source code on an open source repository like GitHub, for instance. Otherwise, it means that the code is not publicly available, and this will make the task much more complicated. The contract API. This part is more intended to be read by a web app than by humans. It describes everything you can do with a contract, and this is what you will need if you want to build a front-end. Most of the information we have here, we will find it under the read and write section. Contract creation code. Here we can find the bytecode. Bytecode is compiled code to be executed by the EVM. It's good to know that is exactly what is being stored on the blockchain, not the human readable version. In case you don't have the source code, on Etherscan you can find a button here to decompile the bytecode. This is an interesting option, but it doesn't always work, as you can see. Finally, the last interesting section is the constructor arguments. The constructor is a piece of code executed only once at the initialization of the contract. Here we can see the parameters with which the contract has been initialized. We can see there is 4 arguments, and we can already recognize some of them. The name, the symbol, 10,000, the max supply, and this is probably a timestamp. We can copy and check this here. Okay, so this timestamp relates to April 22, 2021. Before to look at the contract, I like to check the read and write section. Read actions allow us to see the current value of a variable. It's free and doesn't require any transaction. Write action allow us to modify the variables. This time it requires a transaction and sometimes also some privilege, like be the owner of the contract. Let's have a look at the read actions. No surprise here, we find all the data corresponding to an ERC721 token. If you want to know more about it, you can consult the official ERC721 standard under the specification section. So EIP 721 specification. Here you will find all the rules a contract must implement in order to be compliant. What I am interested in is to see the value of certain variable. This means that the files are stored on IPFS. A variable I like to check is the owner. Here we can see the address 0. This means ownership has been revoked and no one owns this contract anymore. It is not possible to change all the admin variable on the contract, and this is actually very good for an NFT collection. So let's look to the write contract section. Once again, most of the function here came from the ERC 721 standard. We can notice maybe few setters and a withdraw function. Nothing special. Before I copy the code to look at it on my code editor, there is a sweet feature on Etherscan that I want to show you. You will find it under the code section. Here more options and sort to UML. At first glance, this may seem a bit confusing, but it's a simple map of dependencies. Our contract is the rectangle on the bottom left. If we look at the contract itself, we can see only 3 direct dependencies. The first points to the SafeMat library. This has no impact on the logic of the contract, therefore it can be ignored. The second is more interesting. It points to Ownable. This is a standard library that is used to give privilege to the owner. But as we saw just before, the owner of this contract is now the address 0, so this has no impact anymore on the code. Now, the third and last dependency is an implementation of the ERC 721 standard. We can see that all the other dependencies of this diagram came from this class. It is mostly libraries or interface, and for our purpose, this can be ignored. In the end, thanks to this diagram, we can see that there is very little custom code. The only thing to look at is this Ape Yatch Club class here. Okay, now it's time to copy the code in the editor and to look at it. But thanks to all the work we have already made, we have a very good idea of what is going on. On my editor, I made some library adjustments because I don't have the exact same version of OpenSea and I'm not using the same compiler. But this is okay because I don't intend to run the code, I just want to understand it. With all this, we should have something which is very close to the production code. The first thing I want to do is to look at the contract variable. Here they are. We said that we don't care about SafeMat, so I'm just going to comment this. Here we can see there is 2 constants, and let's see where they are used. So we can see this one is used only twice in the code, so once here and once in the min function. And this one, it's also used only twice in the min function and the declaration. Okay, so this, we don't have to worry about it. What else do we have here? This variable sales is active. It's probably controlling the mint flow. So let's find where it is used. We can see we have 4 occurrences of it. The declaration, Then we have a function here that is using it flip save state. This function is only the owner can call it. And we saw that the contract is revoked, so this cannot be changed anymore. And it is used under the mint function. So we can ignore this. We have no more use for this. Now let's have a look to this variable here. We can see there is the declaration and then it is only used here, but this variable is never read by the contract. We only assign it a value. So it actually have no impact into the code. It is never used. It is used as an external record. Let's have a look here to see if it has a value. And yes, we can see there is this value. So now I know that on this page, they provide proof of hash. Let's see if it's matched. Oh, doesn't match. Maybe some white space. Yeah, okay, great. Then we have this three variable. At the moment, we don't know what is it, but we'll find out a bit later. Just so you know, all the / comment here are mine. It is not part of the original code. The constructor. In the constructor, there is only two lines. The first one simply assign the maximum number of ape. We saw before that is 10,000. And then we have a timestamp. This value here could have been calculated off-chain to save gas for the deployer. It's not a big deal, but usually we will avoid to make computation in the constructor if we can do it off-chain. This number is a very common number. It's corresponding to 60 per 60 per 24, which is the number of seconds in one day. And the last comment we can do about this is the reveal timestamp is not a constant. So it's not a common usage to make it uppercase. It's not a bug, it's just a bad practice. And you can see the syntax highlighter here. This is a variable. And because it's uppercase, it recognizes as a constant. So usually if you can change the value, it's not a constant, and then you don't write it uppercase. It just makes it easier to understand what you are reading. Like you see max ape, it's not a constant, but you never change the value once it's in the constructor. So it actually could have been hard-coded as a constant. So it would have been better to do something like this. And then you just do this up equal. And that's it. The withdraw function. The withdraw function allows the owner of the contract to withdraw the ETH that are sent to this contract. As the contract is revoked, it's not possible to do anymore. Also, we can notice that this function allows you to withdraw only ETH and not ERC20 token or ERC721 token. So any kind of token of this type that is sent to the contract is lost forever. And we have some here. So we can see that there is almost $400 value of tokens that cannot be withdrawn, that are locked in the contract forever. So we can delete this. And let's look at the reserve ape function. This function is very interesting. One more time, it can be called only by the owner of the contract. And what does this function? It's simply mint 30 apes, and it is sent to the owner. What is very surprising is that there is no restriction. I understand they are the owner of the contract, so they're supposed to know what they are doing. But there is never a check that you mint more than the max supply. So this function could have been called even if the mint ape function, if the mint was over, because we already had 10,000 ape, and you could end up with like a lot more apes. I think it will be good practice, even if you are the admin, to at least make a check that you don't exactly this one. You don't mint more than the max value that you save for this collection, you define for this collection. And of course, you will mint, in this case here, you mint free of charge. You see this function is not payable, so I cannot receive Ether. Okay, so let's remove this one. Here we have this function, we saw it already, so we can remove as well. This function here allows us to set the base URI, so this is what we saw here, the IPFS link, and it can be called only by the owner, so it cannot be changed anymore. There we go. Oh, he's not happy. Yeah, well, we're gonna left it. Finally, we have the mint ape function. This function is the most important function of the contract because this is the function that allow you to get your token. So what we have here, it's for sanity check. We just check that the sale is active. So this parameter is controlled by the owner. He can open and close when you want the sale, and just like 3 simple checks, like no more than 20 tokens at a time. We just check that the total amount of token is less than 10,000, and that you send the right amount of Ether according to the number of tokens you want. If all this is good, it will mint your token, and it will record you as the owner of those tokens on the blockchain. And then you have these few lines here. So at first it was a bit mysterious what it tried to do here, because the only thing that it does here, it's assign a value to this variable starting index block under certain conditions. And this variable wasn't used before the mint. I didn't know why it was doing this, but the answer is actually just here below. So let's look at this set starting index function. As the name suggests, this function will just assign a value to starting index. You can call this function only once because you check that the value is equal to 0 before to enter the function. And once you assign a value, it's not equal to 0 anymore. You also have a check that if it's equal to 0, then you just add 1. And here, that's where the value is assigned. It tries to do some random value that will be, I suppose, the starting index of the ape. Something we can notice here is that this function is public, so anyone can call it as soon as this variable here is as a value. And so this is not the best way to generate a random number. We could argue that someone could have manipulated this and guessed the value, but we have to be pragmatic, and at the time of the mint, we could not anticipate the success of this collection, so I would say like it does the job. Finally, the last function is emergency set starting index block. This is a way for the owner to unlock a situation where starting index block's variable doesn't receive a value from the mint ape function. This could happen if we don't enter in one of these two conditions here. And this could be the case if we haven't mint all the ape and no one wants more ape anymore. That's all for this contract. Now, something interesting caught my eyes here. Look at this comment. It is rather technical about the block hash function that is used just above. This is in contradiction with the overall mediocre quality of the code. This comment confused me, and after reflection, I found where I had already seen this. Let me show you something. This is the Hashmask contract. Let's look at the deployment date. We can see that the deployment date is earlier than the Bored Ape contract. So let's look at the code now. We are looking for a file named mask.sol. Here is it. And if we copy the comment here and search for this code, it is a perfect match. So let's look at this function. You can see it is exactly the same function. It has maybe not the same name, but everything is the same. The name of the variable, starting indexed, everything is the same. But that's not all. Let's look just above to the min function of the Hashmask contract. If we look at it, we can see it's the exact same structure than the min function of the Ape contract. The requires, the for loop, and then these few lines here. Let's copy this and compare it here. The one in the Ape contracts. We can see it is exactly the same. The only difference is this comment that change here and here. And also we can notice that the emergency set starting index block is present into the Ape contract, but not into the Hashmask contract. So my guess here is that the board Ape, they copy a contract that had already copied the Hashmask contract. Now, is the Hashmask contract the original? I don't know. So is it outrageous? No, because it's common practice to copy bits of code. On the other hand, it is very disappointing to see that the only originality of this contract is not an original creation. And since this code is clearly copied, one can wonder about the ethics of not to mention the original. I leave that to your own judgment. For my part, I find it very disappointing coming from the most popular collection. It's a bit like discovering that in fact the art was not an original creation but a rip-off of another artist. To conclude, this contract is simply a basic ERC-721 token with few extra variables. These variables were mainly used to control the sales, and now they are useless. Nevertheless, there are two variables that stand out. They are never used in the code and have no direct impact, but they act as a simple on-chain record that are meant to be used off-chain. The first one is the Provenance hash. It was calculated off-chain and then recorded in the contract. The second one is the starting indexed. This number was used off-chain to randomize the allocation of the apes. It should be noted that the ownership of the contract have been revoked, hence the data cannot be updated anymore. The code is not particularly beautiful or elegant, but it does the job. It has some clumsiness, but no big deal. As it is mostly based on the open source library OpenSea, unless a bug or exploit is found of one of this library, that is very unlikely, there should be no problem. In conclusion, we can say that the value and the popularity of this collection does not come from its technical side. Before ending this video, I would like to address some controversial points. I have no doubt that the code was copied from either the Hashmask contract or another contract. But on top of this, there is something wrong with the provenance variable. You see, in the Hashmask contract, the provenance hash is hard-coded in the contract. This means that the generation of the image was done before the mint. And in this case, choosing a random starting index to allocate the images makes sense. But with the apes, the provenance hash was recorded on-chain after the mint has started. This means that the team had plenty of time to organize or replace some of the images in any way they wanted. On their website, there is a full section to justify about the fairness of the attribution. The question is, why go to so much trouble trying to prove the legitimacy of the attribution when it's flawed by design? Either the team is dumb and can't even copy-paste some code correctly, or it's an attempt to dissimulate an intentional manipulation of the ape's attribution. But why? Insider trading? Maybe. But in my opinion, the goal was to introduce some Easter eggs. And you might think that Easter eggs are fun. This is true. Except that this time, it is maybe not of the best taste. After I discovered that, I did some research. And it turns out that I'm not the only one who thinks there is something really fishy going on. In a Twitter thread, Fetter Linink is talking about that. Also, I came across this post by Brodan. In this post, he tried to reproduce to compute the hash, and it turned out that it didn't succeed. So maybe it's an implementation error, or you can read the article and make your own opinion. But something is interesting that this hash here, let's copy this and look on this website and try to find this hash. And you can see it is here several times. Finally, there is also this documentary and this website that expose evidence that the team members are in fact neo-Nazi trolls. When you add up all the evidence, it starts to be hard not to think that the allocation was manipulated to insert neo-Nazi Easter eggs. If you want to dig on the topic and make your own opinion, you will find all the links in the description. That's it for this video. I hope you enjoy it and have learned something. In any case, I invite you to vote and choose the next contract I should review on the Discord, the link in the description. By the way, this will also make you eligible to a free mint of my new NFT collection that will be released soon, Mercenaries of Efyria. It's a truly unique and innovative project that disrupts the concept of private property using Web3 technology. Pretty cool. Okay guys, take care and see you.